Hello friends, welcome back. Now let us solve problem set 4. Now again, I'm not going to solve each and every problem, but we are going to discuss all the problems. Okay, this is the combination of all the problems that we have solved during studying chapter 4, that is trigonometry. Let us see problem number 1. If the terminal arm passes through the point 1 minus 1, making an angle theta, find the value of sec theta. Very simple. The terminal arm is passing through 1 and minus 1. So you have x is 1 and y is minus 1. Okay. And so you have to find out the value of sec theta. Sec is opposite of cos. You know x, you know y. So you can easily find out the value of r. And once you get the value of r, you can find out the value of sec theta, because cos theta you know x upon r, so sec theta will be r upon x. Let us go ahead. If the terminal arm passes through the point 4 minus 7, find all trigonometric ratios. X is 4, y is minus 7, so now you can find out r, that is under root of x square plus y square. From that you can find out the value of sine theta and cos theta, that is y upon r and x upon r, and then you can find out all the trigonometric ratios, because tan theta you know sine upon cos, then cosec is inverse of sine, sec is inverse of cos, and cot is inverse of tan. Third example, if the angle theta is minus 60 degrees, find cos theta and cosec theta. We have already learned the trigonometric ratios of negative angles. So we know that cos of minus theta is equal to cos theta and cosec of minus theta is equal to minus cosec theta, because sine minus theta is equal to minus sine theta. So obviously the cosec minus theta will be equal to minus cosec theta. Angle is given 60 degrees, and so you can find out, you know all the trigonometric ratios for 30, 60 and 45. So you can easily write the answer. Fourth example, tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta, cot theta upon 1 minus tan theta is equal to 1 plus sec theta cosec theta. So now how will you solve this? We want here sec and cos, okay, and here you can see that cot is there, so we can eliminate the cot from here. So instead of cot you can take 1 upon tan. Okay, so start from the left hand side, and from left hand side by solving it come to the right hand side. Let us solve this now. So our left hand side is equal to tan theta upon 1 minus 1 upon tan theta plus 1 upon tan theta upon 1 minus tan theta. So we have tan square theta upon tan theta minus 1. Cross multiplying here, tan theta minus 1 upon tan theta, that upon tan theta will go up and will become multiplied by tan theta. So tan square theta upon tan theta minus 1. And here we have tan theta 1 minus tan theta. Now here I have tan theta minus 1 and here I have 1 minus tan theta. So if I interchange, the sign will change. So I will get tan square theta upon tan theta minus 1. Now this sign I will change, 1 upon tan theta into tan theta minus 1. I have interchanged 1 and tan theta. Instead of 1 minus tan theta, I have taken tan theta minus 1. So outside this sign will change. Now if you take the LCM, you have tan theta into tan theta minus 1, and on the top it will be tan cube theta minus 1. Now tan cube theta minus 1 is same as a cube minus b cube, because this is a 1 cube. So now pause your video and first expand tan cube theta minus 1. Take upon tan theta into tan theta minus 1. Please pause your video and solve this step. So this expansion we have a cube minus b cube is equal to a minus b into a square plus ab plus b square. So we have tan theta minus 1, then tan square theta plus tan theta plus 1, and whole upon we have tan theta and tan theta minus 1. So these two will get eliminated. So now if I divide each term, tan square theta upon tan theta is tan theta plus 1 upon tan theta. Now we want answer in secant cosec. So we will take this as sin theta upon cos theta plus 1 plus cos theta upon sin theta. 1 I will keep as it is. I will take 1 first. Then this is sin square theta plus cos square theta upon sin theta cos theta. I have taken these two terms. Cross multiply, and I got this. But as you know that sin square theta plus cos square theta is 1, which identity we know. So 1 plus 1 upon sin theta into cos theta, and 1 plus sin theta is cosec theta, 1 upon sin theta is cosec theta, 1 upon cos theta is sec theta. So we have 1 plus cosec theta into cos theta, that is equal to right hand side. I have started with the left hand side, then I have eliminated this cot and took tan everywhere, went on solving, and finally I came to right hand side. Let us see next example. Fifth example is somewhat tricky. Show that sin theta minus cos theta plus 1, sin theta minus cos theta plus 1 upon sin plus cos minus 1 upon sin theta plus cos theta minus 1 equal to 1 upon sec theta minus tan theta, 1 upon sec theta minus tan theta. Actually, as I told you, that such kind of examples have no meaning. Okay, somewhere you have to start from the left hand side and go to right hand side, or sometimes you have to take some identities and solve it. Okay, so you have to practice these kinds of sum from different papers. So every sum is different. There is no specific rule or specific method for solving this. So you have to remember how we have solved each and every sum. So the practice is only answer to solve these kind of examples. Now let us solve this example and understand this how we have solved thoroughly. Now we know from the identity that 1 minus sin square theta is equal to cos square theta. Now this is a square minus b square. So we have 1 minus sin theta 1 plus sin theta is equal to cos square theta. So now I will just rearrange the terms. So 1 plus sin theta, and out of this cos into cos I will take 1 cos here, cos theta, and equal to, I will take 1 minus sin theta there, cos theta upon 1 minus sin theta. Okay, say this is equal to k. So now by the theorem on equal ratios I will subtract. So 1 plus sin theta minus cos theta and cos theta minus 1 plus sin theta equal to k. I will just rearrange the term. So I have sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to k. Now I will take my left hand side. Can you see this? This is same as this. So now my left hand side is this equal to k. So I will take it as this. So my left hand side, since this is equal to k and these two ratios are also equal to k, I will say this left hand side is equal to 1 plus sin theta. 1 plus sin theta upon cos theta. From I can say this 1 and 2. Correct? I have started with one identity. I came up to some ratio which is equal to left hand side, and in that ratio I have taken the first term as my left hand side. Okay? Now I will solve this is equal to 1 upon cos theta plus sin theta upon cos theta. That is my sec theta plus tan theta. Now I will rationalize. That means I will multiply this by sec theta minus tan theta and divide by sec theta minus tan theta. Okay? So here a plus b, a minus b. So I have sec square theta minus tan square theta upon sec theta minus tan theta. And I know that identity is there. Sec square theta minus tan square theta is equal to 1. So I have here sec theta minus tan theta, which is nothing but my right hand side. I know these sums are quite tricky to understand, but there is no other way than practicing as many sums as possible, because many sums are of different types. So this kind of sum you have to solve in this way. First start with some identity and get some value here, and then solve this. Let us solve next example, number 6. Show that cos square theta upon 1 minus tan theta plus sin cube theta upon sin minus cos. Sin cube theta upon sin theta minus cos theta. Now show that this is equal to 1 plus sin theta cos theta. Now this sum is not that difficult, because we want in sin and cos, everywhere sin and cos are there, only tan is here. So we will try to substitute tan is equal to sin plus cos. Okay? So when you substitute 1 minus sin theta upon cos theta, then solve this denominator and go on solving further. Please try to solve this example by yourself. I told you the trick. Just substitute sin theta upon cos theta here and then go on solving. Please pause your video and try yourself. Let us solve this. So we have left hand side equal to cos square theta upon 1 minus sin theta upon cos theta plus sin cube theta and sin theta minus cos theta. Now I will only solve this denominator, that is cos theta minus sin theta upon cos theta. Now this denominator cos theta will go up and will become cos cube theta. So we have cos cube theta upon cos theta minus sin theta, plus I have sin cube theta upon sin theta minus cos theta. Now here it is cos theta minus sin theta, here it is sin theta minus cos theta. So if I interchange the terms, what will happen? This sign will change. Correct? And I will have cos cube theta upon cos theta minus sin theta minus sin cube theta upon cos theta minus sin theta. Correct? And from here what I'll get? Cos cube theta minus sin cube theta upon cos theta minus sin theta. This is simply similar to your a cube minus b cube expansion, which is nothing but a minus b into a square plus ab plus b square. So this I have cos theta minus sin theta and a cube, and we have cos square plus sin theta cos theta plus sin square theta upon cos theta minus sin theta. Now these two will get cancelled. In this we know that cos square theta plus sin square theta is equal to 1 by the identity. So it will be 1 plus sin theta into cos theta, which is equal to your right hand side. Simple example. Solution was simple, but initially it was quite confusing that how to start. So you have to examine, first of all the practice is the key, but then you have to examine if my answer right hand side is in sin and cos and on left hand side everything is in sin and cos except this tan. So I will substitute tan equal to sin upon cos, and they will try to solve normally by the normal way of mathematics. Okay, let us see next example. If 3 tan square theta minus 4 root 3 tan theta plus 3 equal to 0, then find the acute angle theta. They are given the theta is acute. How will you solve this? This is very simple actually. This is just like your quadratic equation of the order 2. Here it is order 2. If you consider tan is x, then what is the equation? 3x square minus 4 root 3x plus 3 equal to 0. This is a quadratic equation. We are already solved in our algebra. So if you can solve that quadratic equation, you will easily able to solve this quadratic equation. Only in this case tan theta is there in the place of x. So how we will solve this? 3 into 3 9. So we want multiplication 9 and addition minus 4 root 3. Correct? Whose addition will be minus 4 root 3? Minus 3 root 3 minus root 3. So here we have 3 tan square theta minus 3 root 3 tan theta minus root 3 tan theta plus 3 equal to 0. Correct? But for doing this, you should be expert in solving quadratic equations. Correct? In the form of root 3. And I know that whenever the square root in the quadratic equation comes, the students get confused. And either they leave that problem or they make it wrong. So try to solve your algebra thoroughly. Algebra and geometry are not very different. They are connected. Okay? So let us solve this further. So we have 3 tan theta into tan theta minus root 3, and here we have minus root 3 will go outside, tan theta minus root 3 equal to 0. So we have tan theta minus root 3 and 3 tan theta minus root 3 will be equal to 0. So now I'll get two values of tan theta. So tan theta minus root 3 will be 0. So tan theta will be equal to root 3, and tan theta 3 tan theta minus root 3 will be equal to 0. So I will have tan theta equal to root 3 upon 3, that is nothing but 1 upon root 3. So when the tan theta is root 3, what is the angle? Angle is 60 degrees. So here theta will be 60 degrees And when the tan theta will be 1 upon root 3, what is the angle? Here the theta is 30 degrees. Do you remember our triangle? 30, 60, 90 triangle? 1, 2, root 3. So theta is 60 degrees, then tan theta is root 3. And theta is 30 degrees when tan theta is 1 upon root 3. Very simple example. Only you have to solve it just like your quadratic equation. Let us see next example. Find a possible value of cos x if cot x plus cosec x equal to 5. Cot x plus cosec x equal to 5. And we have to find possible values of cos x. How will you solve this? This is very simple, okay? We want to find all the possible values of cos, but here we have the cot and cosec. So simply write them in the form of sin cos. So this will become cos x upon sin x plus 1 upon sin x equal to 5. Now I will solve this. So my cos x plus 1 upon sin x equal to 5, and hence cos x plus 1 is equal to 5 sin x. I want only cos, so I have to eliminate this sign. And how to eliminate this sign? We know that sin square minus 1 is cos square theta, or cos square plus sin square equal to 1. So I will first square both the sides because I want sin square here. So cos x plus 1 bracket square is equal to 25 sin square x. Now I open this bracket or expand this bracket, that is cos square x plus 2 cos x plus 1 is equal to, I will write here 25 into 1 minus cos square x. Okay, because sin square is equal to 1 minus cos square x. Now I will open this bracket again. This will be 25 minus 25 cos square x. Everything I will take to this side. So cos square x plus 2 cos x plus 1 minus 25 plus 25 cos square x equal to 0. How this came to this side? First open this bracket, 25 into 1 minus 25 into cos square x. Then take to this side, so equal to 0. Now cos square x and 25 cos square x is equal to 26 cos square x. Now I have plus 2 cos x and minus 24 equal to 0. Now I can divide by 2. Okay, so I will have 13 cos square x plus cos x minus 12 equal to 0. Correct? Now is it not quadratic equation? Except we have cos x instead of x. So if it is a quadratic equation, how can you solve this? 13x square plus x minus 12 equal to 0. So how will you solve this quadratic equation? Very simple. So we have 13 cos square x plus 13 cos x minus 12 cos x minus 12 equal to 0. So the addition is cos x and multiplication is 13 minus 12. Correct? Now further simplify this. So we have 13 cos x. So we have cos x plus 1, and here we have minus, so we have cos x plus 1 equal to 0. And hence we have 13 cos x minus 12 and cos x plus 1 equal to 0. And so we have, now we can equate both. Either this is equal to 0 or this bracket equal to 0. So either we have cos x equal to 12 by 13 or we have cos x equal to -1. Very simple. Only thing, again a quadratic equation, the reference from algebra, and you have to understand how to solve this. Okay. Since we have been asked to find out the value of cos, I am substituting here cot and cosec by sin cos. Okay. And then just go on solving this, you will get the answer. Correct? Let us solve next example. If tan theta plus sin theta, if m is equal to tan theta plus sin theta and n is equal to tan theta minus sin theta, tan theta minus sin theta, show that m square minus n square is equal to 4 root mn. Simple example. Now you have to show this. You cannot start with left hand side, right hand side, anything like that from here. So what you have to do? We have to show that. We have to prove this. Show that. So we'll start with the left hand side. But again, coming to right hand side is very difficult. So we will start left hand side separate, right hand side separate by substituting m and n values, and then we'll show both are equal. Because even if you solve this, m square minus n square is m plus n, m minus n, it is no way possible to come to right hand side. So we will solve both the sides separately. Okay. So my left hand side equal to m square minus n square. Now I'll substitute. M is tan theta, or you can eliminate one step. You can start with this and you can say this is nothing but m plus n and m minus n, and now we will substitute. So tan theta plus sin theta plus tan theta minus sin theta. So tan plus sin, tan minus sin, those sign will go. I am not writing one more step, or let us write it. Tan theta plus sin theta plus tan theta minus sin theta, and second bracket is I am not writing because I want that space, so I am writing it just below this. It is not denominator, I am just not increasing the length. Okay, and here m minus n, tan theta plus sin theta minus tan theta plus sin theta. So here I will have 2 tan theta into 2 sin theta, that is 4 into sin theta tan theta. Okay, and my right hand side 4 mn. Now we have to multiply these two. Correct? So I'll have 4 into under root tan theta plus sin theta into tan theta minus sin theta. Now is it not like a plus b, a minus b? So I will get here 4 tan square theta minus sin square theta. Now tan I can write as sin upon cos. So I have sin square theta upon cos square theta minus sin square theta. So in the next step I will have cross multiplication here. I will have sin square theta minus sin square cos square theta upon cos square theta. So now here sin square is common. So sin square into bracket 1 minus cos square theta, and 1 minus cos square theta is again sin square theta. So we have sin square theta into sin square theta upon cos square theta. Correct? And so by the under root I will have sin square theta upon cos theta. Correct? Now sin square theta is nothing but sin theta into sin theta. So from 1 sin theta I will take as sin upon cos, that is tan theta. And so I have 4 into sin theta into tan theta. And at last you can write that left hand side. So left hand side equal to right hand side. It is proved. Okay. So in this sum you should be very thorough with algebra, quadratic equations, expansions of brackets, taking square roots, splitting or joining or taking the common out. All these things you must be very expert. Otherwise you are not able to solve these kind of examples. Let us see next example. Example number 10. If sec theta plus tan theta equal to P, show that P square minus 1 upon P square plus 1 is equal to sin theta. Here also we have to use many algebraic identities or algebraic formulas or functions. Okay, let us start with the left hand side. Now here I will substitute by, since I want sine there, I will substitute by sine and cos. So I have 1 upon cos theta plus sine theta upon cos theta equal to P. So I have 1 plus sine theta upon cos theta equal to P. But I want P square minus 1, right? So I will write 1 plus sine theta, I am squaring both the sides, upon cos square theta is equal to P square. Now here algebra comes into field. If you remember 9th standard, 8th standard, componendo dividendo, I am going to use that property. What is componendo dividendo? If A upon B is there, is equal to C upon D, then I can write A plus B upon A minus B is equal to C plus D upon C minus D. This is what the componendo dividendo is, if you remember. Okay. So here I am using the same rule, componendo dividendo 1 plus sine theta square minus cos square plus cos square theta upon 1 plus sine theta bracket square minus cos square theta is equal to, now P square means P square upon 1. So I will have P square plus 1, P square minus 1. But what we want there? P square minus 1 is on the numerator, as a numerator. So we will do now invertendo. So by invertendo I will have 1 plus sine theta square minus cos square theta upon 1 plus sine theta square plus cos square theta is equal to P square minus 1 upon P square plus 1. Correct? Now, please pause your video here and solve this. Can you solve this? Open the bracket, this and this both. I mean expand the bracket and try to solve this. Try to find out the answer. Please pause your video and do it now. Let us do that. So we have, opening first bracket, we will have 1 plus 2 sine theta plus sine square theta minus cos square theta upon 1 plus 2 sine theta plus sine square theta plus cos square theta. Okay. Now I can use identities. This one and this minus cos square theta is sine square theta. So I will combine these two terms and I will use these two terms. Sine square plus cos square equal to 1. So I will have 1 minus cos square theta is sine square theta plus 2 sine theta plus sine square theta upon 1 plus 2 sine theta plus 1. So now I have 2 sine square theta plus 2 sine theta, 2 sine square theta plus 2 sine theta upon 2 plus 2 sine theta. Common out, 2 sine theta is common, 2 sine theta, sine theta plus 1, 2 is common, 1 plus sine theta. Both will get cancelled, 2 will get cancelled, and you will get sine theta, which is nothing but the right hand side of this expression, and hence it is proved. Simple. Only thing you should know what is componendo, dividendo, what is invertendo. You cannot say that we have learned this in 8th standard and 9th standard, so we don't remember it now. You should know each and every method, each and every formula which you have been using from 1st standard to 10th standard. It's very simple, because the 10th standard exam is your exam which finishes your school. So whatever you have learned in your school is there for this exam. So as I told you, if you are weak in algebra, then there is a problem. So better be strong in both. Remember, now we have learned here componendo and dividendo. Write in your notebook right now what is componendo, what is dividendo. Now componendo, dividendo I have used. I shown you there a upon b. If you want to apply the componendo, dividendo, what you will do? A plus b upon a minus b, something like that. Okay, so let's go to next example. If x equal to a sine theta and y equal to b tan theta, then prove that a square upon a square x square, a square upon x square minus b square upon y square equal to 1. Prove that. Extremely simple. I am not going to solve this. Let us discuss this first. So what is a equal to? X upon a equal to sine theta. What is y upon b equal to? Tan theta. What we have here? A upon x. So what is a upon x is cosec theta and b upon y is cot theta. Now we know the relation, cosec theta and cot theta relation we know, correct? So but we want square here, so square both the sides. So we have a square upon x square is equal to 1 upon cos square theta, and here b square upon y square is equal to cot square theta, correct? Because 1 upon tan is cot square theta. And so then subtract. You know this term, substitute and prove that it is equal to 1. Here we are going to use the identity cosec square minus cot square equal to 1. So here you will get cosec square minus cot square equal to 1. The identity is proved. Very simple. Explain to you again. Here x upon a is sine theta, correct? But we want a upon x, so invertendo. So we have a upon x is cosec theta. So squaring both the sides. So a square upon x square is cosec square theta. Here y upon b is tan theta. But what we want here? B upon y. So reverse it. It will be cot theta. And square. So b square upon y square cot square theta. And cosec square minus cot square equal to 1. Simple. Let us solve next example. Problem number 12. Again simple one but tricky. Again algebra we have to use. Let us see what it is. 12. If a cos theta plus b sin theta, m is equal to a cos theta plus b sin theta, and n is equal to a sin theta minus b cos theta, a sin theta minus b cos theta. Prove that a square plus b square, prove that a square plus b square is equal to m square plus n square. So we want m square plus n square. I am starting with right hand side now because m and n I know what are they. So m square plus n square, square of this bracket. So I am doing square directly. Square of this bracket plus square of this bracket. How will you square this bracket? The first term square, a square cos square theta plus b square sin square theta plus 2 ab sin theta cos theta, and plus n square. So now I'll n square a square sine square theta plus b square cos square theta minus 2ab sine theta cos theta plus, because m square plus n square, so these two will get cancelled, and I have, now check this, cos square and a square and a square are here, so here a square is common for these two, so I have a square sine square plus cos square theta, and plus here b square are common, so I'll have b square sine square plus cos square theta, and hence sine square plus cos square theta is 1 in both the cases, so I have a square plus b square, which is equal to right hand side not right hand side, by mistake don't write it right hand side, because we have started from right hand side and we have come to left hand side. It is proved. Simple. Just squaring and opening the brackets. Don't, this is a little bit lengthier one, confusing one. Okay. If you don't have practice of this kind of solving this kind of long sums, then you will definitely make certain sign mistake or AB mistake or sin cos mistake. Okay. Let us see next example. Example number 13. Again a tricky one. If sin theta plus sin square theta is 1, if sin theta plus sin square theta is equal to 1, prove that cos square theta plus cos raised to 4 theta equal to 1. Cos square theta plus cos raised to 4 theta equal to 1. We have to prove this. Now, here sin theta plus sin square theta, I can write this one as sin square theta plus cos square theta. Correct? Now, from this I can subtract or eliminate sin square theta. So, I got now sin theta is equal to cos square theta. This is my first one. From this I came to this. Now I will take left hand side. Cos square theta plus cos raised to 4 theta. What is cos square theta? Is sin theta. And what is cos raised to 4 theta? Is sin square theta. But it is by given equal to 1. From given. Actually, this sum also has got no meaning at all. But still, you have to solve it. Okay? So let us see next one. If root 3 tan theta is equal to 3 sin theta, if root 3 tan theta is equal to 3 sin theta, find the value of sin square theta minus cos square theta. Find sin square theta minus cos square theta. They are given that the theta is not equal to 0. The theta is not equal to 0. Very easy sum. Don't you think so? Because we want to find out this value, sin square theta minus cos square theta. Okay? Now here, tan theta is given, sin theta is given. Now first, let us simplify the given. Okay? So, from this statement, I will have root 3 sin theta upon cos theta is equal to 3 sin theta. Of course, this sin will get cancelled, and we will have root 3 upon 3 is equal to cos theta. And so, cos theta is equal to 1 upon root 3. Okay? Now, let us come to here. We want to find a value of this. So, we have sin square theta can be written as 1 minus cos square theta minus cos square theta. Correct? So we have 1 minus 2 cos square theta, and from here we know the value of cos square theta. If we square both the sides, so we have cos square theta is equal to 1 upon 3. So let us substitute this value there. So 1 minus 2 upon 3. So we have cross multiply. So 3 minus 2 is 1 upon 3. So this is the value of sin square theta minus cos square theta. This example was very easy. Okay. Now the rest of the sum of problem set 4 is on applications of trigonometry. Now as I told you before that if you want to solve these problems perfectly without any mistake, then read the problem first. While reading, draw the figure. If you don't understand how to draw the figure, just imagine yourself on that point. That means if they say that boy is standing and looking at the top of the tree, imagine yourself you are standing here and looking at the top, so that it will be easy for you to draw the figure perfectly. If they say that a plane is here or ship is here and you are on tower, just imagine yourself at that position and then decide if this is angle of inclination or elevation or angle of depression and where the angle can be. If it is depression, angle will be like this from upside. Okay. Elevation, it will be like this from the horizontal to elevated point. Okay. So let us solve example 15. Again, I am not going to solve the calculation part of it. Let us discuss the problem first, draw the figure, then I will tell you how to solve it and you are going to solve the problems. Example 15. A tree 12 meter high is broken by the wind in such a way that its top touches the ground and makes an angle 60 degrees with the ground. At what height from the bottom is the tree broken by the wind? Now whenever you are drawing such a figures, remember, give x to that value which we have to find. Okay. So now our figure is something like this. This is the ground, this is the tree broken, and the same length is up to here. Correct? This is making angle of 60 degrees. We want to find x, and this part is nothing but 12 minus x, because the complete height of the tree is 12. Okay. So this part is 12 minus x. Now it is very easy. So we have sin 60 is equal to x upon 12 minus x. We know the value of sin 60. Sin 60 is nothing but root 3 upon 2 is equal to x upon 12 minus x. So let us cross multiply. So we have root 3, 12 minus x is equal to 2x. Please pause your video and solve to find out the value of x. Please do it now. Now the calculations are very easy, but I know that you must have stuck somewhere here because of this root 3. Because dividing something by 1.73 is not possible orally. You have to use either calculator or log table. Calculators are not allowed. Log table, it is difficult. So now we will try to eliminate root 3 as a denominator. Okay. Let us see how to do that. So we have 12 root 3 minus x root 3 is equal to 2x. Just rearrange the terms. So we have minus x root 3 minus 2x is equal to minus 12 root 3. So let us eliminate these minus signs. So we have x is common, root 3 plus 2 is equal to 12 root 3. And so we have x is equal to 12 root 3 upon 2 plus root 3. Now the problem is you can easily take, because the value of root 3 is given 1.73. But if you substitute value 1.73 here, the denominator will be 3.73. And dividing by 3.73 to this is difficult. So let us rationalize this denominator. How do we do that? Just multiply by 2 minus root 3 upon 2 minus root 3. Now this is nothing but a plus b, a minus b. So we have here 12 root 3, 2 minus root 3 upon 2, square of 2 is 4, 4 minus 3, that is 1. So now you don't have to worry about the denominator. Okay, this is nothing but a square minus b square. A square, that is 4, b square is 3, is 1, 4 minus 3 is 1, so you don't have to worry about it. Now you can solve it very easily. Okay, so now just substitute the value of root 3, that is 1.73. So here 2 minus 1.73 multiplied by 12 into root 3. Please quickly do these calculations. The answer is x is equal to 5.52 meters. Please check your answer. Give unit, don't forget to write meters. Okay. Let us see next example. Example number 16. A person standing on the bank of a river observes, that means there is one river, bank of a river. One bank, second bank, equally opposite side. Observes that the angle of elevation of the top of the tree on the opposite bank is 60 degrees. Now, when he moves 40 meters away from the bank, that means he is standing on this bank, he can see on the another bank top of the tree with some angle of elevation. Now he moves back 40 meters away from the bank, and again he watches that tree. Then what happens? When he moves 40 meters away from the banks, he finds the angle of elevation to be 30 degrees. Find the height of tree and width of the river. Root 3 is given 1.73. Let us draw the figure first. Very simple figure. This is the horizontal line. I am standing here at point A and point B. A and B is the river. So one tree is here. Let us call it C. When I initially watch this, it is angle 60 degrees. And now I am moving to point D, which is 40 meters away, and now when I see at the tree top, this angle is 30 degrees. Now you have to find this x and this y. Okay, very easy, figure is easy, so the solution is also easy. Now you have two triangles. First triangle is this bigger triangle where the angle is 30 degrees. So what is tan of 30? X upon 40 plus y. Another triangle, tan of 60, x upon y. So please pause your video. You have now two variables and two equations. So you can easily find out the value of x and y. Please solve it now. Let us see this. I am not going to solve up to the solution, but let us write down. Tan 30 is equal to x upon y plus 40, and tan 60 is equal to x upon y. Now in this case you know the value of tan 60. Tan 60 is root 3 is equal to x upon y. So what is y is equal to? X upon root 3, correct? Or x equal to y root 3. Substitute this value in this equation. This equation tan 30 is there. Tan 30 is nothing but 1 upon root 3. And substitute this value there. You will find x or y. Then resubstitute here and you will find a remaining variable. So please pause your video here and solve till end. The answer is x is equal to 34.60 meters and bank of the river is 20 meters. Please check your answer. Let us go ahead. Problem number 17. The angle of elevation of a cloud. Now the cloud is there. Okay. Angle of elevation of a cloud from a point 60 meters above the lake. We already solved this kind of example. is 30 degrees and the angle of depression of the reflection of the cloud in the lake is 60 degrees. You have to just remember one thing. If the cloud is there at say 100 meters from the surface of the lake, its reflection will also be 100 meters deep inside the lake. Okay, but right now I am standing, suppose this is the surface of the lake, problem number 17. If this is the surface of the lake, I am standing here 60 meters above the lake. So I am standing 60 meters above the lake. Okay, cloud is here. Let us say A is cloud. So its reflection at B, this is will be same. Correct? Now this is 60. So this is x minus 60. From here, the angle of elevation is 30 degrees. And now when I see at the reflection, the angle of depression is 60 degrees. This angle is 60 degrees. Now once you get this figure, the rest of the things are very easy. What they ask? Find the height of the cloud. So we have to find x. So now let us run this. So we have cloud height is x and this distance is 60 as I am standing 60 meters above the lake, and this is x minus 60. So now we should have two variables and two equations. So let us take this as y. So now two equations we have. The first equation, tan 30 is equal to x minus 60 upon y, and second equation we have tan 60 is x plus 60 upon y. Simple. Tan 30 1 upon root 3, tan 60 root 3. So first try to eliminate this y, substitute there, and then you will find the answer. The answer is height of the cloud is 120 meters. Please check your answer. I am not going to solve this as that will be spoon feeding, but when two equations and two variables are there, you can easily find the answer for that problem. Let us see next problem. Problem number 18. A man on a cliff, so I am standing on the cliff, observes a boat at an angle of depression 30. I am standing on a cliff. I can see the boat at the angle of depression of 30 degrees, which is sailing towards the point of shore immediately beneath him. That boat is coming towards the shore. 3 minutes later, the angle of depression of boat is 60 degrees. Angle of, now since it is far I can see there, now it is coming here, I have to see here. So initially the angle of depression was 30 degrees, now it is, angle is 60 degrees. 3 minutes later, okay. Assuming that the boat sails at uniform speed, determine how much more time it will take to reach the shore. Now first draw the diagram, okay. Let us draw the diagram first. I am standing here on the cliff. Okay, I saw the boat here. This is my line of vision. I saw the boat at A first. Then I saw the boat at B, C, and let us see this is D. So first when I saw the boat, my angle was 30 degrees. Now can you see these two lines are parallel? So this angle is also 30 degrees. Now at the point B, after 3 minutes, this angle is 60 degrees. So this angle is also 60 degrees. Correct? Now again I am telling you, don't just complicate or confuse your example by writing the names of the segments. I am just going to write this as y and x and let us say z. Okay. Now from B to A took 3 minutes. Now let us consider our two triangles. Tan 30. What is tan 30 is equal to y upon x plus z? And what is tan 60 is equal to y upon z? Correct? Now, we have tan 30 means tan 30 is 1 upon root 3. So, 1 upon root 3 is equal to y upon x plus z. So, we have x plus z is equal to root 3y is the first equation we got. And tan 60 is root 3. Correct? Tan 60 is root 3. So we have z root 3 is equal to y. Now can we substitute in case of y? Y is nothing but x plus z upon root 3. I am taking it here. So z root 3 is equal to x plus z upon root 3. Take root 3 here. So 3z equal to z plus x. 3z is equal to x plus z, and so x is equal to 2z. Correct? I am writing this z in running script, but if you are confusing between 3 and z, instead of z you can take p, doesn't matter, or you can take p, q and r, these 3 points, p, q, r, something like that. Here I have taken z because I have a habit of taking z and writing this in cursive. But now x is equal to 2z. Correct? So this distance is doubled. Z is half of x. Correct? Now to cover the distance x, it takes 3 minutes. So if the boat is moving, they said that the boat is moving with a uniform speed. So how much time will it take to cover the half of its distance? Half the time. That is, to cover z distance, it will take 1.5 minutes. This is your answer. Now again I am telling you, instead of x, y and z you can take p, q, r. So you will not be confused between z and 3. Okay? Pause your video and do this example by taking p, q and r. You will get that this distance is double this distance. Okay? So cover, we want to find out the time to cover CB. So you can easily find out this 1.5 minutes. If you consider that in triangle ACD, then the tan 30 is equal to DC upon CA, and all those things if you take, you are definitely going to commit some mistake somewhere. Personally, I don't like to use the segment kind of things. I like to use the variables, give names to variables. In case of angle also I do same thing. I directly call that angle as a theta or alpha or beta, something like that. Okay? So the calculation part, in the calculation part, it will be easy to understand and easy to solve. You will not get confused anywhere. So let us move to next example. Example number 19, very easy. A circus artist is climbing from the ground along the rope stretched from the top of the vertical pole and tied to a peg at the ground. You might have seen circus. Okay? The rope is tied here on the ground and pole is there. And the rope is from the top of the pole to rope. Height of the pole is 12. That pole height is 12 meters and the rope is there. Okay? We are considering there is no slack in the rope. Okay? The angle made by the rope with the ground is 30 degrees. Now angle made by the rope and the ground is 30 degrees. Calculate the distance covered by the artist in climbing up the top of the pole. That means you have to find out the length of the rope. Extremely easy example. I am not going to solve. Just this is the pole, this is the rope, this is 12 meters, this is making angle 30, and you have to find x. Extremely simple. Okay, you just have to say sine 30. Sine 30 is 12 upon x. What is sine 30? 1 upon 2. So we have sine 30 is equal to 12 by x, that is 1 upon 2 is equal to 12 by x. So x is equal to 24 meters. Very simple. Let us see the last example of problem set 4. Example 20, interesting example but simple. Okay, a bird was flying in the line parallel to the ground from north to south. Ground is here, line parallel to the ground from north to south, the bird is flying. Tom standing in the middle of the field. Tom, suppose I am standing here in the middle of the field. The bird was flying in a line parallel to the ground from the north to south at a height of 2000 meters. Okay, this is the ground. The bird is flying from north to south in the line parallel to ground at the 2000 meters. That the height of the bird is 2000 meters. Tom standing in the middle of the field. I am standing in the middle of the field. Okay. First observe the bird in the north. Now first I observe the bird in the north at an angle of elevation of 30 degrees. So what is the angle of elevation will be? From here, this is my line of vision here. Now I watch the bird here. So this angle is 30 degrees. After 3 minutes, he again observed it in the south. Now after 3 minutes I observed the bird was there at an angle of 45 degrees. Now this is my line of vision and I watched him at a 45 degrees from the ground. Okay. Find the speed of the bird in kilometers per hour. Find the speed of the bird in kilometers per hour. So let us first draw the figure. This is my ground level. I am standing here at A. This is the line of the bird flying. This is north, this is south. First okay, this distance is 2000 meters, that is 2 kilometers. Okay, first I watched the bird to the north and the angle of elevation was 30 degrees. Now on the south, when I watched him, the angle of elevation was 45 degrees. So this is the simple figure. Correct? Now I want to find out the speed of the bird in kilometers per hour. To find out the speed of the bird, we have to find the distance he covered, because I watched him after 3 minutes. So the time is equal to 3 minutes. Correct? Now I have to find this distance. I'll say this is x and this is y. I am going to find out this distance in kilometers. So if this is 30, this is 30, if this is 45, this angle is 45, because the ground and this line are parallel. Now in the first triangle we have tan 30 is equal to 2 upon x, and in second triangle we have tan 45 is equal to 2 upon y. Correct? Just pause your video and find out the value of x and y, and so the distance traveled by the bird. Please pause your video and do it now. So tan 30 is 1 upon root 3 is equal to 2 by x, and we have tan 45 is 1 is equal to 2 upon y. So here we have x is equal to 2 root 3 and y is equal to 2. So we have distance travel, that is d is the distance traveled by the bird, is 2 plus 2. 2 root 3 plus 2. 2 is common. So root 3 plus 1, that is 2 into root 3 is 1.73. So this is nothing but 2.73. So the distance traveled by the bird is 5.46 kilometers. This distance is traveled in 3 minutes. So if in 3 minutes 5.46 kilometers. So how much distance it will cover in 60 minutes? Don't by heart any formulas or so. This method you have learned in standard 3, and practically any example can be solved by this. Just remember, minutes below minutes, kilometers below kilometers. Okay? So in 3 minutes this, so how much distance it will cover in 1 hour? That is 60 minutes. That is 5.46 into 60 divided by 3. That will be your speed of kilometers per hour. Answer is 109.2 kilometers per hour. So friends, with this example we have finished the problem set 4, and along with that we have finished the chapter Trigonometry. The chapter was very easy and we have solved so many examples. Just remember in this case that draw the figures perfectly, and in case of prove that where the 4.3 was there, you have to do lot of practice for solving those examples. The examples are of hardly 4 to 5 types of examples are there. When you solve each type at least 20 to 25 examples, it will be very easy for you. For that kind of thing, I will suggest that go through the past year papers, go through minimum 50 papers, specimen papers or past year papers, find out the examples related to your trigonometry and solve those examples so that it will be easy for you to solve any problem related to your trigonometry. So friends, here we have finished the chapter Trigonometry. Thank you very much.